have f is a finite function whose domain is the letters a to e. The following table lists the output of each input in f's domain. All right, so the output is the bottom row here, and the input is the top row here. So what we can do is we can kind of write a mapping diagram to see now if the function here is invertible. Okay, invertible. So all right, that means if we inverse it, it still remains a function. Right, so we have here for as a domain of x, a, b, c, d, and e. Okay, and then we have the list of numbers here. Let's write them out from small to biggest. So we have negative 19. Okay, and then we have 7, negative 19, 7, and 23. Okay, so let's map these things. This is f of x here. Let's map these things. So a maps to negative 19, b maps to 23, c maps to 7, d maps to 23. Okay, and e maps to negative 19. So here we just finished mapping. Now, this is a function because each input has one output, okay? One unique output. However, when you do the inverse, when you look from the right side and see if we inverse it, right? So now the output becomes the input and the input becomes the output. So once that happens, we want to check to see if that function, that invertible function, the inverse is still a function. So let's look at negative 19. Negative 19 will point to 2 output. So this alone defeats the whole thing, because now you have one input producing 2 outputs. So we'll see f is not a function.